Hi there, welcome to my channel Mando to Fundo. In this video, I'm going to discuss about the solution for adding two numbers represented by the linked list. Let's look at the problem description. We are given a two non-empty linked list which represents two numbers and their digits are in the reverse order. For example, here 342 is represented by the linked list like in the reverse order 2, 4, 3. So we have to add these two numbers and return the output list. Let's take a look at this example 1. Here the list 1 is 2, 4, 3 and list 2 is 5, 6, 4. So when we add, it's 5 plus 2 is 7, and when we add 6 plus 4 10, but we have to store only a single digit, so carryover is 1, which we have to add with these two numbers, and finally we get it. So the final output should be 708. With a single number 0, 0, the output will be 0. In the case of example 3, the list 1 size is greater than the list 2 size. So what we do is we add the numbers in L1 and L2 until we process the size of the smaller list, and then the remaining list we simply add only the carryover from this addition and then return the final output. For the number of nodes in each linked list is in the range 1 to 100, and the node values will be between 0 to 9, and it is guaranteed that the list represents a number that does not have a leading 0. Let's look at the approach to solve this problem. We have two input lists. One is of size 4, second one is size 3, and when we add the numbers in both of them, which will form a list of 4 elements. We maintain two pointers, one pointing to the head of the first list and a second one pointing to the head of the second list. And then we have to traverse both the list until one of them hits the tail. So in this case, after processing 3, each iteration we add these two numbers. If there is a carryover, then we pass it on to that number to the next iteration, so that carryover plus these two numbers will be added, and this sums carryover will be passed on to the next iteration. So until we reach the list 2's tail, we advance both the n1 and n2 pointer. Once we hit one of the nodes tail, then we have to process the remaining elements in the other list. In this case, the list 1 has one extra element. So what we have to do is whatever the carryover comes from this addition will be passed to this, and then this node we add that carryover to this number and add it to the output list. So in this case, if you see 5 plus 2 7, 4 plus 6 10, so we add 0 here and the carryover will be 1, pass it on to the next iteration, which adds 1 plus 3 plus 4, which is 8, and there is no carryover, so we just simply add that 1 to the tail. So finally we get this output list. Let's look at the flowchart. Input for this procedure is list 1 and list 2. So first we initialize the pointers L1 and L2 such that they point to the head of the list 1 and list 2. Then we initialize the variable carryover to 0 and initialize the head and tail pointers for the output. So initially they both are null. Then we are traversing the nodes in both the list until one of them reaches the tail. So if L1 is not null and L2 is not null, then we make a call to a function add node, which takes the carryover plus the L1's value plus the L2's value, that sum, and then address of the output list head and the address of the output list tail pointers. So inside that function it will be a simple singly linked list addition, and in addition to that, that function will return the carryover from this sum, and that carryover will be passed on to the next iteration. So after returning from this add node, we advance the pointers L1 and L2. So either one of them reaches tail, then we have to process the remaining elements in the other list. In case if L1 is not empty and L2 is processed completely, then we have to do the same calculation. We have to call the same function. Instead of adding the L1 value and L2 value, because L2 is empty, so we just add only the carryover and L1 value and pass the current the head pointer and the tail pointer of the output list. Once that function returns, then we advance the L1 pointer. Same way for the L2. Instead of passing L1, adding the L1 value, we add the L2 value with the carryover and pass it as a sum to the add node function, and then pass the head and tail pointers. After that, we advance the L2 pointer. So when we come out of these three loops, we process all the nodes. And then if there is a carryover from the last node's computation, then we have to add a node for that carryover value. So we create a new list node and add that to the tail of the output list, and then we return the head back to the caller. Let's move on to coding. First I initialize the carryover variable to 0, and then I declare the head and tail pointers. And then the first for loop, which traverses the elements until one of the list is fully processed. So here on each iteration I call the add node function, which takes the sum and then the pointer to the head and pointer to the tail. So in this case, when both the nodes present, the sum will be the carryover plus the node the L1 dot val plus L2 dot val, and then we pass the pointer to the head of the output list and pointer to the tail of the output list, and this function will return the updated carryover value, which will be used in the next iteration. So after that add node function is returned, I advance the pointer L1 and L2 to the next node in the list. So once either one of the list is fully processed, then we need to process the remaining elements in the other list. For example, if there is an element left over in the list L1, then we have to process that. So in this case, because the L2 is empty, so we just pass only L1 dot val plus the carryover value, and then on each iteration after that I advance the L1 pointer. Same thing I do for the other list, where I pass only the carryover plus L2 value as the sum. Then I check whether the final carryover is greater than 0. If so, we have to add a node for that value and add it to the tail of the list. And finally I return the output head of the list. Next I am going to implement the add node function. This function basically add the new node to the output list, and also it will return the updated carryover for the sum value. So first I compute the carryover by dividing the sum by 10. The quotient is used as the carryover, and then we create the node with the remainder value and the nil next pointer. Then this is a typical singly linked list insertion. So if the head is nil, then the new node will be set as head as well as the tail. Otherwise, we add the new node next to the tail node by setting that current tail dot next equals to the new node, and then update the new node as the tail node. And finally return the new carryover value. Next I am going to run the test cases. Oh, there is a compilation error. I think I need to use the indirection. Okay, all the tests passed. Next I am going to submit this program. Cool, this program is accepted. Next I am going to do the code walkthrough with sample input. So we have two input lists, list 1 and list 2. The list 1 is 2431 and list 2 is 564. The expected output is 7081. So first the carryover is initialized to 0 and we declare the head and tail pointer for the output list. So in the first for loop we iterate over the linked list until we reach the tail of one of the list. So first L1 points to the head of list 1 and L2 points to the head of list 2. Then we call the add node function with the carryover plus the L1 value plus L2 value. So carryover is 0 plus L1 plus L2 is 7. So we pass the value 7 and the address of the head pointer and the address of the tail pointer. So here we compute the carryover from the sum by dividing that sum by 10. In this case 7, so the carryover is 0. And then we create a new node with sum modulo 10. First we compute the carryover from the sum by dividing that by 10. In this case 7 divided by 10, so in this carryover will be 0. But we have to use the remainder of that division in assigning the value to the node. So node created will be sum modulo 10. So in this case the output will be 7. The node, we create a node with the value 7 and then we check whether the head is null. This is the first time, so head and tail are null. So what we do is we assign the created node to the head point, make the head pointer to point to that newly created node, and the same way the tail pointer also made to point to the newly created node. This is in the first iteration, and the carryover 0 will be returned back. Then in the iteration 2, the L1 and L2 point to this. Here 6 plus 4 10. So when we compute the carryover here, it will be 1. So that's why we see the 1 value. 10 modulo 10 will be 0. So we create a node with value 0 and make because the head is not null. So we come here, we make the current tail is next to point to the newly created node and we update the tail. So now we have 7 and 0 and carryover is 1. So in the next iteration we come here 3 plus 4 plus the previous carryover 1, we pass 8 to add node function, and then the carryover will be 0 and then the new node will have value 8 and that new node will be added to the tail. So we have tail points to the node 8. And then in this case we reach the end of the second list. So we come out of this loop. Next we enter the loop which process the remaining elements in the list 1. So first we so the L1 is pointing to this node. So we add the carryover from the last computation, which is 0 plus 1, and we call the add node function, which adds that node 1 to the out list. So finally we get 7081 as the output. Next I'm going to do the time and space complexity analysis for this solution. Okay, let's do the time complexity analysis for this input. The input list L1 has 4 elements and L2 has 3 elements. Let's do how many iterations this for loop performs, and this together. So first for loop will run for the size of the smallest list, which is 3 here. So this will run 3 times, and then the L1 has extra 1 element, so this loop will run once. So totally 4 iterations it performs. So the time complexity is the order of m, where m is the length of the longest list. So in this case 4. And the space complexity is order of m, where m is the length of the longest input list. The output will be equal to the longest list size. So we need a space for that 4 elements. So that's why the next let's do the space complexity analysis. So if we look at it, the final output needs space for 4 elements, and the 2 input list sizes 4 and 3. So at the end we need a space of size which is equal to the longest list size. So the space complexity is order of m, where m is the length of the longest input list. Thanks for watching this video. Have a great day.